Okay, so the elasticity of demand changes along a linear demand curve, and somewhere along there it equals 1. Now, just by coincidence, we had 1.08, but somewhere along there it's 1, which we were pretty close to that. What does elasticity of 1 mean? There's still a change going on, but kind of run through that interpretation that we just had.
Is it a slope of 1?
No, it's not slope.
Well, it's for every...
Because the slope is constant, but the elasticity changes. And so what I'm saying is that somewhere along here, the elasticity is 1. So read off that definition. I'm sorry, not definition, interpretation.
It would mean a 1% increase in price means a 1% increase in quantity.
Right, the 1-to-1, right? So just this 1-to-1 thing. So anyway, that's got kind of an anchoring spot for us. And that anchoring spot has a special place graphically that I want to show you now. So watch this. If you take the midpoint between a linear demand curve and where it intersects the horizontal axis, if you take the midpoint and come straight up, that is where the elasticity of demand is unitary. So we say it's unitary elastic. And it's just not too big of a deal. It's just a 1-to-1. Change price by 1%, quantity decreases by 1%, or if it was an increase. Everywhere to the left, the elasticity of demand is less than 1, but greater than 0. So we saw one example of that. We were at 0.35. And this is known as the inelastic range of the demand curve. So over this whole area, from kind of here to between and up here, it gets close to 1. And then, guess what the numbers are up here? Good, more than 1. And we say that demand is elastic. This is the elastic range of the demand curve. Now, just so you have a placeholder, I'm going to tie in a graph here down below. So do that. But before we get there, I want to show you one other step with the formulas.
What is the word next to when it's equal to 1?
Unitary. Unitary elastic. So from the formula, if the elasticity of demand is greater than 1, it's elastic. Note that that implies that the percentage change in quantity demanded is greater than the percentage change in price. I'll rewrite the formula here just so that you guys probably have it in your paper, not too far away, but percentage change in quantity demanded over the percentage change in price. All it's saying is that if this number happens to be bigger than 1, the numerator is bigger than the denominator. And that's all we're saying. If it's equal to 1, then these two are equal. And of course, if it's less than 1, then that implies that this one is less than this one. Keep things nice and brief, all right? So this all kind of ties together. Formula or equation goggles, graphing goggles. So that's kind of the connection here. All right. So where we start to use it, especially in managerial economics class, is its relationship to the cash register in terms of total revenue. Total revenue. That was our half of the profit equation that we were concerned about. And the revenue function looks like now, and then we'll describe it. If you take this little dashed line and come down, and then draw king of the hill here, that looks like this, and this comes into here, and this is at the origin. That is the total revenue function. Just price times quantity. I use the word function, but it's not too sophisticated, right? Price times quantity. What's significant about that? What's that telling you? And now if we start to look at the two up above, notice that this is the inelastic range. This half is showing what's going on with the elastic range. Here, that price will maximize revenue. Yes. Is that where you should be?
Yeah. You want to maximize? Oh, no,
Oh, good. You caught yourself. What are we trying to maximize? Profit. This is only one half of the equation. So we're not out to revenue maximize. We're out to profit maximize. We'll get to that other part of the equation later. We've talked about it a little bit, though. I guess I might as well. What was the shape of the marginal cost curve? What did that thing look like? Yeah, Muhammad gave me the Nike swoosh, right? So as I start to produce more units, what happens to my cost per unit at the margin? Each additional unit goes up, is what this marginal cost curve says. So yes, we might be growing revenue, but if my costs are escalating at a quicker rate, it might not be a good thing to do. So we want to maximize profits. It's the interrelationship between those two. All right, I didn't want to get distracted too much, but it's always good to kind of pull that back in because you really want to keep these concepts separate for now. So, Clay pointed out revenues are maximized here. Good. What else? Can you tell me about what this picture is saying? What is, when companies want to spur business, what kind of their knee-jerk reaction that they tend to do when they want to sell more? Discount, lower the price, right? It's always about price, right? And that's kind of the knee-jerk reaction that I like to question people on to make sure they're carefully thinking about that. And this example tells us an interesting thing, is that if we lower price here, and I move from point A to point B, if I lower price and I move from point A to point B, I am snaking along the demand curve, right? Those 2 points correspond directly on the revenue function with A prime and B prime. And that's why this graph, this is one of my favorite graphs, by the way, in Econ. This one's kind of fun to me. A prime and B prime. A decrease in price leads to a what in revenue? An increase, right? Because look at the graph, we're going up the revenue hill. A decrease in price leads to an increase in revenue. That's people's knee-jerk reaction. Now, if we're over here, though, here's the one that's a little more counterintuitive for people. Moving from point C to point D, and I do the exact same $2 price increase, or decrease, by the way. So, right, the way we did that before, we do the same $2 price decrease. That corresponds on the revenue function with C prime and D prime. And a decrease in price led to a decrease in revenue. Total revenue goes down. Now you got to be scratching your head and saying, well, why? I don't get it. You decrease price here, revenues climb. That's what we wanted. We decrease price here, revenues fall. Why?
Because at that point, people don't want it or something.
Okay, you're kind of close.
Because there's so much of it that people don't value it as much.
Okay.
And, like if you have too low price and then people are like, oh, it's not even good quality.
Okay.
Do your costs end up outweighing?
We don't have any costs, so I don't want to go there. We don't have any costs. We're just purely looking at cash register receipts.
And the discount is the same from A to D.
Yeah, let's just assume it's a $2 drop here and a $2 drop here.
The demand is inelastic at that.
All right, good. I thought you were going to do that on your first answer, but you didn't come to that. It depends on the elasticity of demand. So, what we know from the law of demand is that a decrease in price leads to an increase in quantity. But from the revenue picture, this one going down is bad. This one going up, good. So we've got these two countering things. Erica, a little minus point?
Fine. I'm trying to take a picture of it once.
Perfect, no problem. I just wanted to make sure we're clean. So price goes up, quantity goes down. Price goes down, quantity goes up. So we got these countering things, right? In terms of the revenue function, we want revenues to go up, but it depends on the elasticity of demand. Because if you're doing let's stick with a price decrease is bad. But if the quantity effect is huge, then that's good still. That's capturing the elastic portion of the demand curve. The quantity effect overwhelms the price effect. So if I think over here with this equation, I like to kind of think in terms of these arrows. We do a price decrease, but if that price decrease is a little arrow and the quantity effect is a big arrow, the big arrow overwhelms the small arrow, we're golden. Revenues climb. But if the price arrow is relatively big and the quantity effect is small, the big arrow overwhelms the small arrow and revenues fall. And that's exactly what we're seeing here with that relationship, all due to the elasticity of demand. And so some business owners make that mistake thinking, well, how do I stir up business? Funny thing is, the answer might be to do what? To actually increase revenue. Increase your price. If the demand is inelastic for your product, the answer is actually to increase your price, not decrease it. That's kind of bizarre, right?
Yeah, it's kind of counterintuitive.
But you can kind of think of things that are inelastic, people really want, right? You can kind of charge whatever price you want. Well, if you can have a small quantity effect by jacking up your price, raise your prices 50%. Oh, I'll lose some customers. The law of demand tells me that. But if I only lose 2% customers, that was a good move. And then to add on to this, if you raise your price, you lose quantity, what happens to your cost? It actually goes down, so that we got this moving in the right direction now. You are absolutely golden in terms of profit maximization if you face an inelastic demand. Good luck getting that, by the way. That's not an easy position to get at, right? But if you're the inventor of a new product and you're the only show in town, you probably face a relatively inelastic demand until competition kicks in and then we start getting into substitutes and all that kind of stuff, which is where we're kind of heading next. All right, last comments on that.
I have a question.
Yes.
So if you're taking into account the entire graph that you show here for total revenue, would you say that on the second half, after unit elasticity, would you say revenue is going down, or that it's increasing at a slower rate than it was in the first half?
The rate of change. The rate of change depends on the steepness or flatness of the demand curve, which is kind of where I'm going to be heading next. So it is curved as we got it shown here. The main thing is that a price decrease causes a decrease in revenue. That's the part that you got to hang your hat on. Is just what we said there.
Okay.
Okay. All right. So let's go to the extremes. You know, we've got all these extreme sports nowadays that are kind of mainstream now, but now we're going to talk about some extreme econ with elasticities. Yeah.
Could you explain one more time why? How does it benefit to increase the price when the demand is elastic?
So if the demand is inelastic and we reverse what we're doing here, we had a price of $8 and we're going to raise the price to 10, right? So an increase in price is good for revenue, but we're going to lose customers. But the amount of customers we lose is relatively small. And so an increase in price in the inelastic range causes revenues to fall or to climb as well. That's just kind of the mechanics of the graph. So what I like to tell students is to kind of have this picture memorized, because there's a whole bunch of multiple choice and short answer problems that are embodied in it. So for instance, one would be worded kind of like what we've been doing. If demand is inelastic and there's an increase in price, what happens to revenue? If you observe revenues falling when you had a price decrease, what was the elasticity? Elastic. You see what I mean? You can kind of ask all kinds of questions around this concept of elasticity. This picture captures all the answers to that. Okay? All right, so extreme elasticities. Boom. Demand curve, perfectly vertical. Boom. Demand curve, perfectly flat. Okay, this is perfectly elastic. So perfectly elastic is that picture. We say that demand is perfectly elastic. And this one is perfectly inelastic. So if we think about the Mona Lisa, the quantity is 1. There's 1 Mona Lisa, right? Right? This would be, I'm sorry, that was a bad example actually. The supply of Mona Lisas would look like this. The demand might not look like that. We might have different demands, but there is only 1. Whoops, I still wanted to keep the demand. I was just trying to explain the elasticity. All right, so let's work through the formula really quick. Elasticity of demand is the percentage change in quantity demanded divided by the percentage change in price. On this weird demand curve, if we pick 2 points on it, we've got some number here for quantity, but P1 equals P2 here, right? Price is the same, quantity changes. So we get some number, the percentage change in quantity, new number minus old number divided by the average. We get some number divided by 0. No change. 0. Some number divided by 0 equals 0. Some number anything divided by 0. Is that right? It's indivisible. Remember that 5th grade math teacher? I had Mrs. Von Berg, that we kind of called Mrs. Von Bag, but we weren't very nice back then. She said, remember this rule? You can't divide by 0. So you can't divide by 0. That was the rule of math. So, now that we are in graduate school, though, we can outwit Mrs. Von Berg and divide by something really close to 0. like 1 over 1 million. If I take some number divided by a really small number, like 1 over 1 million, does this end up being a big number or a small number? Some of you are like, oh, wait a second, Russ, that's not close enough to 0. I want you to get as close to 0 until you're comfortable. So if that's 1 over 1 zillion, or 1, I don't know what those big numbers are, tera something zillion, you get as close to 0 as you want. What happens to this number, this expression? As this gets really small, what happens to it? Keith gave me the sign language. It gets really big. What do you do with a fraction in the denominator to solve this little, a number divided by a fraction?
Invert.
Invert. Thank you, Keith. Invert the denominator, multiply it times. You want to put a zillion here, it's some number times a zillion. It is infinity. It blows up and gets as big as you want it to be. You can't divide by 0, but you can divide by something close to 0. So this is infinitely elastic. So perfectly elastic demand curve has a elasticity of infinity. It's infinitely elastic. Now, this one I saved for the 0 people. Price, some number, quantity, 0, elasticity of demand, percentage change in quantity demanded over the percentage change in price. Percentage change in quantity is a big fat 0, some number. 0 divided by some number is, now I got you all scared. 0, yes. You can divide anything by 0, that's not a problem. So this perfectly inelastic demand curve has an elasticity of 0. Now that's kind of what was going on with this graph. As we move towards the vertical intercept, this number is getting really close to infinity. Like the closer you snug up to the vertical axis, it blows up to infinity. The closer you snug down to the horizontal axis, it equals 0. You never get there, but you get close to it, right? And so that represents your endpoints on a linear demand curve, downward sloping linear demand curve. Here's your 2 extreme cases. And we will use both of these extreme cases. So it's just something to think about. We'll get to this one next week, especially the perfectly elastic demand curve. All right, now, the real world. So let's talk about the tweeners. Here's what I mean by the tweeners. What about one that's kind of steep or kind of flat? Steep or kind of flat. First is the kind of steep one. Would you call that relatively inelastic or relatively elastic? Inelastic, good. Here's the one little secret thing to remember. The more and more steeper it gets, the more it starts to look like an I for inelastic. All right? So these are relatively inelastic curves, and this is relatively elastic. Just kind of the terminology that we'll see with these. Another way to think about it, since we have this distinction, is that if I went to some obnoxious prices that don't make any sense for Mountain Dew, like what if a Mountain Dew was $166,000? You know, well, the demand curve still continues up there. Where the midpoint is here. You go up. There's the unitary elastic point, the elastic range, the inelastic range. So what we're visibly seeing is really all numbers that fall in the inelastic range. So we kind of just refer to it as being relatively inelastic. Okay. Anything else there? Well, all of that was price elasticity. And now we have income elasticities and cross-price elasticities. We can have an elasticity for actually anything. So what we're trying to measure is the responsiveness of the consumers to a change in something. Price elasticity is a change in price. But now we can go back and apply the same logic to income and prices of related goods. So, as a segue into that, let's think about the things that impact the elasticity of demand. So before we get there, things that influence the price elasticity, which we've been doing, the price elasticity of demand. So one way to think about this is the flatness or steepness of the curve, i.e. the flatness, if you want to think about it, this is kind of layman's terms here, the flatness or steepness of demand. So what I'm thinking about is what causes a demand curve to look like an eye, or what causes it to more look like a flat pancake over here? What are the factors that influence the price elasticity of demand? Gasoline, relatively inelastic or elastic? Gasoline, to your personal life. Are you responsive to price changes? Or when price changes, you pretty much buy what you used to buy? Still got to buy it, right? Now, if price jumps from $3.29 a gallon to $6 a gallon, are you going to respond a little more? What are you going to start to do? Tell me about what would go. Let's face it, it could happen. Drive less. By doing what? Bike, right? Find alternatives. What else? So biking.
Horse.
What's that?
Horse.
Horse. Okay. We're going to go way back to horse and buggy. Okay. Carpooling, right? All of a sudden you're like, hey, maybe we could ride together, which you wouldn't do because you're okay paying $3.29 a gallon. Jumps up to $6, you start carpooling, right? So a lot of people think that Americans have gas prices too low. Heck out of gas, because then people will start using less of it, better for the environment, blah, blah, blah. So otherwise, in reality, many governments around the world will tax gasoline because they know it's fairly inelastic and they're not going to lose tax revenues by taxing it. Same thing with booze and cigarettes, all those things that tend to have a little more inelastic demand. They're better things to tax. All right, so things that influence the demand, one of the main things I want you to put down is the availability, because we'll come back to this topic in later chapters, the availability of substitutes. The availability of substitutes. I'm not even going to write it down, but there's a couple other things like the fraction of your income that it makes up. So if bubblegum prices go up from $1 to $1.20, that's a 20% increase. You're like, I don't care. But if a car goes up 20%, you're like, I'm not buying that car, right? Because it represents a larger fraction of your income. So little tiny items, we can get away with a little more latitude. They tend to be more inelastic if it represents a smaller fraction of your income. So I'm not going to write that one down because I want you to really remember this one for future items we're going to come into. The availability of substitutes. So more subs means more elastic or inelastic? More. Now write this down and then think, because this is one you kind of need to buy into. That's why I wanted to emphasize it tonight.
More elastic.
More elastic. That's correct. So if there's a whole bunch of substitutes and somebody jacks up their price, if McDonald's doubles their price for their shake,
McFlurry.
Shamrock shaped McFlurry, if they double their price, what do? Run to Wendy's, run right across the street. Availability substitutes, which means McDonald's doesn't have a lot of pricing power. If they raise their price even 30 cents, they're going to lose a whole bunch of customers. They're all going to run across the street to Wendy's, right? So there's a big response. It's relatively elastic. So more substitutes means more elastic. A bigger response. And again, in layman's terms here, a flatter demand curve. Graphically, we'd visually be looking at the flat one. Okay. So let's see here. Got one more thing to nail you with here on this before we leave this chapter. I'm just going to write them down quickly, those other elasticities. So we got the income elasticity, which is the percentage change in quantity demanded divided by a percentage change in income. This is all in your book. Kind of write this down just so I think conceptually when you review your notes, you'll see the connection again. So this is the income elasticity. Then there's also something called the cross price elasticity, and I think, yeah, that's what your book uses, that terminology. Cross price elasticity. Percentage change in the quantity of Coke. I'm just going to start you off with an example. The sales of Coke is also dependent upon the percentage change in the price of Pepsi. A price of a related good. So now we can test the sensitivity of, well, what if Pepsi raises their prices? What happens to us? Cross price. So let's work through that little mental gymnastics here to try to predict the sign of the cross price elasticity for substitute goods. If the price of Pepsi goes up, the quantity of Coke goes up. Pepsi's more expensive, people go buy Coke, right? Pepsi drops their prices, quantity sales of Coke goes down. So if we calculate these numbers, similar to what we did with the price elasticity, substitutes are going to have a positive sign or negative sign when you crank out the numbers. Positive, same direction as those price changes, right? So with Coke and Pepsi, I'll put one little extra note here because again, this is something we'll look at later. A cross price elasticity, let me just write that a little differently. For substitutes, like Coke and Pepsi, the cross price elasticity of demand is greater than 0. The number is a positive number. And sign matters. For complements, peanut butter and jelly, like PB and jelly. Price of peanut butter goes up, jelly demand goes, quantity demanded goes down. So peanut butter and jelly sandwich is more expensive now, so I'm going to buy less jelly too. I'm also going to buy less peanut butter, by the way, but I'm going to buy less peanut butter by the law of demand. Peanut butter prices go up, I buy less peanut butter, but now I'm also going to buy less jelly because I want them for my sandwich. Those two goods are complementary goods, they're complements. So for complements like PB and J, the cross price elasticity would be less than 0, negative. So for this elasticity, unlike the negative sign that we got with the price elasticity, sign matters. A positive sign means the two goods are substitutes. A negative sign means the two goods are complements. Sometimes we don't know necessarily what they are. Like we talk about peanut butter and jelly, it's like, oh yeah, of course they go together. So maybe it's beer and wine. Substitutes or complements? Substitutes, right? Everybody substitutes a wine for a beer. I don't know, if you're going to throw a party and you're having a bunch of people come over, what might you want on hand for your party?
And what kind of people are coming over?
True.
We use by beer and wine.
Beer and wine for your party, right? So that you could cater to different people, different tastes. So in that way, for a party, beer and wine are complements with each other. We tend to buy them together. If we're a boozer, we buy all kinds of booze. So maybe they're complements, right? So that's the type of thing that economists investigate, is to see what those two things are. And more importantly, you know, it goes beyond the sign. Sometimes we want to look at the sign, but we're really interested in that number. If Pepsi jacks up their prices 10%, how much is that going to help us or hurt us? Well, again, we can interpret the number the same way. If the cross price elasticity is a 5, a 1% increase in the price of Pepsi will lead to a 5% increase in Coke sales, right? So all of a sudden we put meat on the bones on quantifying what the number means and how it's going to impact our company. Okay. I got one last one. That's an application of elasticities, just so that we had it on the board. We talked about break even last time, and an economist I don't know who to give credit for unless it's in the book right here, came up with a stay even analysis. And this is kind of interesting. Stay even analysis. It's kind of similar to the break-even analysis, except now what we're thinking about is how many units am I going to change by to stay even if there's a price increase. So if I rack up my prices or change my prices, what quantity do I need to stay even in terms of revenue? See, just like what we were doing before. And so it's a nice little application here, but thinking about the quantity that I need to stay even by looking at the percentage change in price divided by the percentage change in price plus this little factor. And there's a bunch of math that goes behind this, but the intuition is kind of nice, just using the formula. And that's what it looks like. It's kind of ugly. Write that down and then we'll talk about it. So we got the percentage change in price divided by this weird factor, percentage change in price plus this little creature. This little creature we saw. You might even want to pick on Brandon just from what you said earlier today. What is price minus marginal cost? That had a name. Price and marginal cost, the difference between the two. So if a unit costs me $5 and the price is 8 minus 5 is $3.
Is that what was called a contribution factor?
Good. The contribution margin. That's right. So good, Keith. So this is the contribution margin, which we talked about before in a different context, which was with the break-even analysis. Now we're using it, tying it into our elasticities. Okay. The thing that's nice about this is we don't actually have the elasticity in it. So this comes about from the elasticity, but look at what we've got here if you're a boss of this company. Do you know what price you're currently selling Pepsi at? Yes, right? Do you know what your cost is? Yes. If you're proposing a 10% increase, you plug it into this formula and you can determine the quantity that you'd need to stay even. Now we might think, well, we're going to get a lot more. Again, it's kind of one of those decisions of, this is what I need to stay even. Does this number feel right to me that I should do it? If I'm looking at a price increase, how many customers am I going to lose? Or if I'm looking at a price decrease, how many customers am I going to gain? And is that going to be enough to offset? So kind of think about volumes, and it gives us a number with the quantities. And again, we know our current quantity, and so we can kind of work from that and get some information. All right. That is chapter 6. So chapter 7, we just have, it's literally 4 pages long. So not too terrible. I'm going to hit it with some PowerPoints since we've been lecturing at the board the whole time so far. Let's see here. I need to open it up. Oh, I don't know if any of you looked, but the PowerPoints are on the Blackboard shell. They will populate after we're done with class. And so they're up there now for the ones that we've gone through, and after tonight's class, they'll populate.
I have a question.
Sure.
So for the stay even analysis,
Yes?
will we just need to know the formula and be able to plug in the numbers, or we need to understand how it comes about or any of them?
In the text, no. Knowing the formula and knowing how to plug it out, yes. And then also just I think this will help you work through it, kind of the concept of it, that we're able to think about the quantity effect for a given price change and how much we need to stay even. So yeah, if you've got those 2 parts, that's what I'm looking for. All right, so let's see here, screen share. Okay, so boom. All right, good deal. Here we go. Let the fun begin. Okay, we talked about this last time, that costs were increasing. And that is a little bit of a slippery topic of, well, why would costs go up? So like if you are making hamburgers and burger can be purchased at $3.50 a pound, if I go buy 10 pounds, it's $3.50 a pound. Well, what's the cost of another bag of burger? $3.50 a pound, $3.50 a pound, $3.50 a pound, $3.50 a pound. So you start to kind of wonder, like, oh, that doesn't make sense. Like, it seems like we can always buy more. And if anything, Sam's Club gives us a discount for buying more burger. So what's going on with those costs versus what seems to be in our gut? And the answer lies in the production process. And this is something that is a top principle of economics, the law of diminishing marginal returns or the law of diminishing marginal product. I want to give you one quick snapshot to burn into your memory to kind of hang on to this, because it's important in terms of that physical production process. So I used to be a cook, and I might need a prop for this. So back in the day, I could slay a pretty mean burger, and I worked at a little Greasy Spoon restaurant, and this was, actually, Keith, I need to take you off. Stop share. There's going to be lots of acting in this, so you got to see this. All right, so this is my grill top, right? I'm the worker, I'm the laborer, and I make hamburgers. And so if I come to work, I found that my productivity is about 100 hamburgers. So working by myself, I can put together 100 hamburgers. All right, so this is my grill top. This is where I do all the flipping. If I add another person on, another cook, onto the shift, what will happen to the quantity of burgers? Will it go up to 200?
No.
It'll stay at 100 with 2 people? And more hamburger, of course. You got more variable products. So we do actually buy the $350 bound burger. I add a person.
On that grill.
Can we make more with 2 people?
Well,
I mean,
Well, you could.
yeah, I mean, you could.
collectively you can make more, but each of you is not going to make more.
Okay, so good. So we got the idea. We should see production go up if I'm adding resources to it, right? So my question is, I could do 100 by myself. Let's say that we're identical people. Somehow we've got the genetics thing figured out and we cloned a Russ. And so now we've got 2 Russes coming in. Will the 2 Russes make 200 burgers, less than 200, or more than 200?
Less than 200.
Less? Is it possible that they could do more? Can you imagine any circumstances where maybe the number goes up to 210, which would mean, of course, that the extra person added, the 2 of them working together could do 210 instead of something less than 200?
Yeah.
How? Working together, and what else? What kind of stuff goes on with working together? Just expand on that. Or anybody.
Separating your, separating.
Assembly line separation of task. Adam Smith, specialization of labor. Now he comes in, I patty up the burgers while he's tending to the buns and flipping the burgers, right? So through specialization, we might be able to actually increase productivity, meaning that the marginal productivity for me was 100 hamburgers. The marginal productivity for my second Russ, by the way, identical in skill and everything that comes in, the marginal product of that worker was 110 burgers. Our total product as working together is 210. Got the difference here? Marginal product versus our total product. By the way, don't stop there. What's my average product? Because I have 2 workers, if I'm making 210 hamburgers, what's the average productivity of labor? 105. See the differences there? Big distinction. Remember we had first lesson, I don't know if that was first week or last week. Don't confuse average and marginal. Huge mistake. Average and marginal are 2 different things. Now, Russ number 3. Do we have this increasing thing going on again? Could. Russ number 4.
You can get to a point.
There's going to be a point where
Russ number 5. Russ number 6. Russ number 7. Russ number 8. Russ number 9. Where are we at now here? How much is the extra burgers is that extra 8th Russ bringing on, able to add? Very small, maybe still positive though. Maybe we can squeeze out 8 more burgers. But once we've reached the virtually production capacity of this grill top, the key to this whole exercise is that yes, we could change burgers, yes, we could change buns, yes, we could change lettuce, yes, we could change Russes, but we couldn't change the size of the grill top. Capital. So the amount of capital, at least one resource was fixed. And so as you add more and more of a variable resource to at least one fixed resource, the amount of product from each additional unit of labor eventually falls. The extra russes that come in have to have diminishing, whoops, it's no longer up here, diminishing marginal product. The law of diminishing marginal product, it has to hold. There's not a production process out there that won't hold as long as you're keeping one thing fixed. Okay, so that's a huge thing, because now when it comes back to pay, what am I paying each Russ? Same, yeah, the 725. I can hire as many Russes as I want. So the 8th Russ costs me the same as the 1st Russ, right? So what's happening to the cost per burger when the 8th Russ is diminishing marginal product, but the cost of each additional Russ is staying at 7 1/4? The cost end up going up. Every additional hamburger, as we graph it out, will go up. The law of increasing cost, that J-shaped swoosh, the law of increasing cost comes about from the law of diminishing returns. And that's sometimes the counterintuitive thing that we see happening with when we look at cost in isolation. We don't think about the increasing cost. But when we think about the entire production process, it makes sense if we phrase it that way. Okay, so that is law of diminishing marginal product, important law. All right, still sharing. Here we go. Okay, so here they add a couple comments on why we might see that. Monitoring, so I didn't get into it on this particular illustration, but the Russes start talking to each other. Hey, what are you doing this weekend? Are you going over to this party? No. So there might be lack of productivity, what economists call shirking, like slacking off. That's the econ term, is shirking. So we might have that type of thing going on, and all of that leads to that J-shaped marginal cost. All right. There's the picture we did last time, how that affects the average. Remember, the marginal cost curve intersects the average at the minimum point. By definition, it has to. That's when the GPA, if our semester GPA is the same as our overall average, it stays the same. Okay, so learning curves. Look at what's going on here. Airplane manufacturing costs, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 planes. Marginal cost. Going up or down? Down. Total costs. They're going up. Average cost going down. When the marginal cost is below the average is falling. What we are is on that front end of the J shape. And that's where we can have huge productivity increases. Kind of like my adding the second Russ, right? Like, oh, we've got good things going on. There's a learning curve. If I bring new people on, it takes them a while. And once they get working together, once we've learned how to make the first plane, then the second, third, and fourth become easier. There's kind of a learning curve to the process. So that would reflect itself in the numbers that way in terms of the graph. Over this quantity, when you're talking airplanes, if we kept going again, kind of like we did on the other thing, to 20 planes, 100 planes, somewhere out here, that marginal cost curve turns up. Because the law of diminishing marginal product is going to kick in. But in the airplane industry, it's always at this little short side because the demand in the market isn't that big yet. There's not a big enough market to make 100 planes. There's only 10 going up of the production process. So we kind of stay in this range as the relevant part. All right, here's a little example. So Gibson guitar. Do we got any guitar players? Any musicians who play some guitar? Okay. So what's the fingerboard play? What part of the guitar is that? The fingerboard. The neck, yeah. The part that you see people, and they're running their fingers, right? So rosewood and ebony is used for these high-end guitars. But we had some issues with the ebony. So some ebony has these brown streaks. All right. It's still better than the rosewood from a, this goes beyond looks, aesthetics, but it actually plays better, sounds better with the ebony. So they tend to use the streaked ebony on these lower end guitars because the look, so the performance is still the same, but it doesn't look quite as cool if it's got the streaks in it. All right, so if we start looking at the cost of our guitar business, and we think about the cost of acquiring ebony, and maybe ebony comes in, we can buy it in its pure form, or we just have to buy it in aggregate. Some's going to be streaked, some's going to be white, right? And so our pure white. So what does the cost, if we have to buy it in bulk, what is the cost of the streaked ebony? If we're in the business of making guitars that are pure, what is really the cost of the streaked ebony, the marginal cost? Should be lower, right? So, in fact, if we have to buy the product in bulk, and we usually are, I'm kind of telling us, weaving in a little story here, but when we started making guitars, we always had pure ebony on there. Did I say ivory? Ebony, ivory. So when we had the ebony, we always used the pure because it looked the best. And we'd always buy it, and then we'd have this extra ebony. So now when I have it, the marginal cost of the ebony is 0, other than maybe some handling costs, or it's very low if we weren't using it. So then the guitar maker says, well, this is going to work the same. Maybe we should just make a middle guitar, make something else out of it. Now you go through and do that. That was the logic of the economic decision at the time, right? The cost of this extra product was really 0 because you had to get the ebony shipped in for that way. Light bulb goes off, let's produce these guitars. But now when we go backwards and we look at the accounting and we're a year into it, and we say, well, what's the cost of this guitar? Well, the cost has maybe changed because we've changed our production process. And now we buy a block of ebony and we attribute, well, 40% of this block was the streak stuff and part of it was the pure stuff. And so now we start allocating costs a little bit differently. So the accounting method for calculating the cost can be different than the economic way. And so the point of that is that economists operate on the margin. We're always on the edge of life. We're the fun ones. We're not the bean counters that are doing it after the fact. We are on the front lines, right? So that's why marginal costs are so important. You got to learn how to frame the question right, or the issue, and how to move forward and not get lost in some of the, maybe the actual dollars spent. What's more important is, what do we got? How do we move forward, right? So the marginal costs and marginal benefits, even if the accountant calculates it differently after you're done. Okay, so what we're looking at here is called economies of scope. So another illustration before we get into the definition. Suppose a small family company makes, sells, distributes popular breakfast sausage. Can this firm realize economies of scope? So what scope economies are is providing multiple products. And by doing so, you have a lower cost. So we have companies that offer a variety of products, right? Manufacturing places, they do a variety of offerings. Why? Why do you have multi-product firms instead of examples? So we can kind of play with that if we want.
You're not going to satisfy all the consumers. So if you have more, you're going to try to reach a bigger...
Put a different value on the
Yeah.
product.
Okay. I agree with what you guys are saying. Playing off this guitar example, they could provide, when they started their business, they provided just the guitars with the pure ebony, right? How have they lowered costs by producing now 2 guitars?
Well, they don't have to pay for another building, they don't have to pay for
Good.
employees, you're right. we can buy
Okay,
that.
so we've got a lot of that overhead operating cost that might work, coupled with the fact that we might have a production process that further shares those things. So we're not in the guitar and amp business, right? I'm just trying to think of something that was way off of a guitar. But maybe a violin and a guitar, even though I know those things are pretty far off. But maybe the producers of it, some of the materials, the raw materials are similar. See what I mean? So the closer we are in the product offerings, the more we might have what economists call economies of scope. So from a formula standpoint, is this. The mid-range guitar, the high-end guitar. Producing those jointly is less expensive than producing the high-end and producing the low-end at different facilities, right? That's economies of scope. All right. All right, can you guys think of any other types of scope economies? Here at Ottawa, since a lot of you work here. There's kind of different examples. It doesn't, we got this guitar business in our head, but just think of where we're offering multiple things.
So like for housing that we offer, like single room apartments.
Okay, good.
with the same staff.
Yeah, yeah, we might have multiple staff to offer different types of rooms. Good. There's kind of lots of examples once we start thinking about it.
All different majors.
Different majors, right? So we're a school, well, we've got a business major, maybe we should do accounting. Well, okay, we need to hire an accounting professor, which is an additional cost, but we still have the program together and we got everything else. So yeah, we could have multiple offerings.
Gymnasium, so we can offer these different sports.
Okay, different
There's some
sports,
different-
yeah. So wrestling. Got a really nice thing that is started up, but they're going to hold their events in the Wilson Athletic Building where we do basketball and volleyball, and so there's a separate program of volleyball and basketball would cost separately if you needed an arena, you needed all that, but to offer them jointly, it's much less, the total cost of providing it. All right, good. So that's economies of scope. Yeah, let's do this example, and then I've got one other little one. So, pet food company has 2,500 products. Who knows what a SKU is?
That's what the numbers you use to scan.
Good. Yep. So you've done some of that work. That's right. So that is the scanning number, that unique product identity. Believes there's some economies of scope about price. Walmart tends to beat up its suppliers. I don't know if you guys know that. That kind of is in the news off and on. Another interesting thing about Walmart is when they go green, they kind of strong arm their suppliers into going green, and then they get the benefit of it. It's kind of one of their little secrets. So Walmart says, oh, we are saving, let's say, X% of recycled material or whatever. You need to cut back on your material waste, and you need to give me a report that proves that you did it. Why? So that they can aggregate all that data and say, Walmart protects the environment. When really what they did is they kind of strong-armed their suppliers into being environmental. And then, of course, they throw in a couple lights, and they alternate their lights flip-flopping, and so then they look... So it's a maneuver called greenwashing, where we can kind of give the perception, and I'm not saying they're terrible. Walmart has done more for the world in terms of low prices than just about any other company. So I don't want to get all anti-Walmart on you, but this is the reality, right? You can kind of make those types of maneuvers. I mean, we buy lots of cheap stuff. If we aggregate all of our savings across the world, the amount of employment and everything that they've done is just, it's really amazing. So, so I kind of got off tangent there. So they strong-armed this pet food place. And so the pet food place has an idea. They're going to shrink their offerings. So this one is kind of taking what we just did with economies in scope and kind of turning it around a little bit, because they're heading the other direction. For this particular company, what they found is that they were running all of these multiple products that they thought, well, I have a gymnasium, we can have volleyball, we can have basketball, we can have this, but they maybe didn't think about all what was going on in the production process in terms of the setup time. And so there's other costs that might be going on. In this particular case, again, this is just an example to get the juices flowing. By reducing the number of product offerings, they were able to eliminate these run times and reduce their costs, which then allowed them to sell their product at a reduced price to satisfy the threats that they were getting from Walmart, that they were going to move suppliers. Okay? So, this teeters on the other last concept we're going to talk about tonight, and that is economies of scale. So that was economies of scope. Economies of scale is kind of similar in that we're looking to reduce costs. But how we do it with economies of scale is we just increase quantity. So by increasing quantity, we're able to move down along the cost curve like we saw with the learning curve. By increasing the number of airplanes from 10 to 20 to 30, we see economies of scale. We're still just making airplanes, one product, but by producing more of them, we can enjoy economies of scale. So a reduction in cost that's due to increasing the scale of production. Economies of scope, decrease in cost by spreading out production, going to multiple products. So let me write out the economies of scale definition, because I want you to hang on something that tends to screw up students here on the definition. So economies of scale is a decrease in average cost due to an increase in quantity produced. And then we'll put kind of parentheses the scale of production. Sorry, Keith, I'll change to the board here real quick. Maybe I always look at the wrong cursor. So economies of scale, a decrease in average cost due to increasing the scale of production. We've seen this in a couple of our graphs, economies of scale. That's why I wanted to start with economies of scope. That one, the graph isn't easy to do because you got multiple products. But here with economies of scale, we have a long run average cost curve that looks like this maybe. And I drew this kind of goofy for a reason. So long run average cost. So as I increase the scale of production from 10 to 20 to 30, I have some decreases in average cost in the long run. Average costs are falling. That may not last forever, though. That doesn't mean you can just keep building infinitely that you'll never. So it's likely that this might level off at some point. Now, I snuck in the word long run here. So long run versus short run. Question mark. I think this has been in your reading, but it might not have been. So let me just put it out to you. Does anybody know the distinction on the long run versus the short run in economics class? And I'll give you a hint. It has nothing to do with time. Well, time is part of the answer, but it's not like 1 year is the long run and 3 years is long run. It has to do with what you factor into what?
Does that have something to do with your fixed costs?
Yep.
So basically it's the point, the lowest point on that scale is like the side short run. And then once you hit that lower point, then you're into the long run?
No. So this curve here is showing all long run. So again, the distinction's not that, is not that part.
I remember one class you said something like, in the long run, all costs are variable.
Good, that's right. How are all costs variable in the long run? What are costs generated from? Fixed costs, variable costs, you guys have kind of been bouncing around the right thing. Where do fixed costs come from that they're fixed, or where do variable costs come from that they're variable? In the long run, all costs are variable.
I totally interpreted that wrong.
Did you? That's all right. Well, now hopefully we'll get to the right one. So it comes back to the inputs. So when you have a fixed cost, it's because there was a fixed input, right? Potentially a fixed input. But in the long run, we can vary the size of our space and everything else. So in the long run, all costs are variable means that all inputs can vary. So the long run, all factors of production, all resources, whatever we call them, all inputs to the production process can vary. I'll use that word vary because then that triggers what you said. In the long run, all costs are variable because all inputs can vary. We can change the quantities of the inputs. In the short run, at least one thing is fixed. Today at the restaurant, the size of my grill is fixed. I can vary the labor, I can vary the hamburgers, but at least one thing is fixed. So in the short run, at least one input is fixed. Okay, so economies of scale is a long-run concept. So a decrease in long-run average costs due to an increase in the scale of production. So I'm going to add one more thing onto this picture, and you guys can add it later. These are short-run average total cost curves. When we look at our pictures, we are looking at this average cost. We're in the short run. There's a marginal cost curve that cuts through the minimum. And what this is depicting is that if we choose, I like to use real estate partially because I was a real estate guy. If we're in a small manufacturing building, the average cost looks like this. If we get into a medium-sized facility, we can lower our costs. So if I'm making 30 units regularly in my manufacturing plant, I would be better off to be in the medium-sized building, right? Because the small building, there's just not enough room. Everybody's piled on top of each other, right? And so that drove up my average cost per unit. However, if I'm producing 20 units, kind of week after week is kind of my production amount, I'm better off being in the small building because the medium-sized building is a little too costly. I'm not pumping out enough units to justify that big of a building. And so my average cost would be higher. And so in the long run, I can pick any frickin' size building I want, right? So I can be in the small, medium, or large, and I will do that as I grow. In the short run, I'll be trapped kind of on one of these, but in the long run, I can be anywhere. And so you're always going to be looking to be at your lowest cost possible, and that is the outer envelope of an infinite number of these curves. I only drew 3 of them, but if you can kind of imagine doing the square footage business, there's an optimal size building for my production process that minimizes cost. And that's what this long run average cost curve is. Okay, so that's kind of economies of scale, economies of scope. This little chapter is just about 4 pages long. Let me see here. Got this one question we're going to go back to, and then I think we are done. Let's see, I got to find Zoom here. There we go. Zoom. Share screen. Boom. Okay, and boom. And boom. Okay, got it. And boom. All right. So, economies of scale, learning curve, kind of similar in concept. The very first unit you make, marginal cost 64. The second, 32. The third, 21. The fourth, 16. The fifth, 13. The sixth, 11. If a potential project comes your way for 4 units, what is your break-even price? Now this one you can kind of do in your head. You don't necessarily have to pull out some formula. But I want you to understand the problem. So thinking about this production process, this is the way the numbers shake out. If you only had to make 1 unit, it's going to cost you 64. The second runs you 32. The third, 21. The fourth, 16. Because there's economies of scale, the marginal cost curve is falling. Those additional units are looking like that. So somebody poses 4 units.
$64.
64. No, not quite. How would you calculate the break-even price? One thing is to calculate your costs. Is that what you're starting to do, Faye? What'd you do?
Divided by 4.
Okay, and divided by 4, so what'd you do? You're on the right track, it sounds like. Divide what by 4 is, I guess, the key.
Oh, that total, the total of those first 4.
Of the first 4.
Yeah.
So what are you doing? 64
Yeah, 32,
plus
21.
32. Okay. So what do we got here? 64 plus 32. What do we got? 96.
That's
21. 96 plus 21. 121 short 4. 117. 117 plus 16. 27, 133, good, 133, and then what'd you do to figure out your break-even price per unit? Divided by 4. So it was your cost of each additional unit, but if you had to quote the price, that would be your break-even price, thinking about it that way. All right, so $48. Everybody get that?
For 2 more units or to make it 4 6?
So it's 2 more units on top of what we had already. So it'd be adding on the 5th and 6th unit. So what is your break-even price on those units? You get another project opportunity. It's a different deal. 2 more units.
So $21.
me what
Yeah.
you're doing. Yeah, tell me what.
Add 5
I don't know.
and 6.
Add fifth and sixth, so 13 plus 11, 24, and then what would you do? Divided by just the 2, right?
So you wouldn't do the whole thing over again with 6?
Not under this context, the way it's worded. After landing the 4-unit deal, a new person comes
Okay.
along and says you get another project opportunity for 2 units. What is your break-even price?
Because you're still already making them.
Exactly. So at the margin, those extra 2 units is only going to be the $12. All right. So there's our numbers, just like what you guys calculated. Here's the key, is if the first project was what's your break-even price for 6 units, your answer is different. Then it was kind of what I think you were going to do before. Again, all of this is trying to highlight for you that at the margin, things look different. As you're making decisions, things look different. So if you're looking to do 6 units, then your average price needed to be 26. With just 4 units, it was 33 to break even. This extra project comes along, it's just 12. Right? So each decision is unique depending on where you're at in the process currently. Whew! Okay, we made it another night. We're done. We are done.